Hello everyone, and welcome to your video on the inscribed angle theorem. So the first thing that we need to do is we need to put into your notes what that theorem says. So go ahead and get out your notes and then write this down. The inscribed angle theorem says that the measure of an inscribed angle equals 1/2 the measure of the intercepted angle. Now I know it's kind of unfair for me to have you write that down since you don't know what an inscribed angle is yet and you don't know what an intercepted angle is yet, so really this theorem makes no sense. But just complicated words, not a complicated process or concept. So let me show you. So here is a circle, and here's a circle with a center, and here is a circle where an angle has been drawn in it. This is called a central angle. And that means an angle whose vertex with its vertex at the center of the circle. Okay? An angle with its vertex at the center of the circle. Okay, so that should not surprise you then to know that there is such a thing as an angle. This will be the inscribed angle. Oops, gotta spell it right. Inscribed angle is any angle if and only if A, B, and C are on the circle. Any angle if A, B, and C are on the circle. So here's the center of the circle. Here's A, here's B, here's C. So you see that it is an angle and its vertex is not in the center of the circle. It is on the circle, but it's not in the center of the circle. So central angle, you have your vertex in the middle. Inscribed angle, you have your vertex on the side. Now I'm just going to make the point now that this type of angle something like that, this, bad news. It is not a central angle, and it is not an inscribed angle. Okay, I don't know what you call that, although it kind of looks like a deformed snowman, maybe Picasso's snowman. In any event, we're not dealing with that. Goodbye. We're just dealing with central angles and inscribed angles. Okay, so now we know that the measure of an inscribed angle, hey, we know what that is, equals 1/2 the measure of the intercepted angle. Okay, so let's go back to this and let's talk about what the intercepted angle is. So here's where A hits the circle, and here's where B hits the circle. And if I were to draw this as a central angle, so if I were to draw a central angle using these points as my points of contact still, this right here becomes my intercepted angle. Intercepted angle. Intercepted angle. And so whatever measurement this is, so let's say that this is, oh, what does that look like to you? That looks like 118 degrees. Doesn't it? Not really. Yeah, let's say 118 degrees. So then that means that this angle right here is going to be half of that. So that is going to be, what is that going to be? 59 degrees? Right? That is what the inscribed angle theorem says. It says that the inscribed angle, ABC, is half the measure of the intercepted angle, 118. So let's just do a few examples of this to make sure that you've got it. So in our first example, here's our circle. And I'm going to draw our inscribed angle like this. Okay? Now, I think this is kind of an interesting angle. You can see that it's inscribed. All 3 points are on the edge of the circle. And it goes through the center of the circle, which is not a requirement of the inscribed angle, but it's kind of interesting that that happened, right? Because that could happen. So what we need to do is we need to figure out our intercepted angle. So I'm going to take this, and then I'm going to draw this as if it were a central angle. And I'm going to measure this distance. And let's say that I know that this distance from here to here is 120 degrees. So what is the measurement of my inscribed angle? Why, it's 60 degrees. Why? Because the inscribed angle theorem tells us that this is going to be half of whatever our intercepted angle is. So it's going to be 60. If I told you 60, then you would be able to figure out that that was 120. Pretty cool, huh? All right, let's draw another circle. So in this circle, we have our center point, and this time, our angle does not touch the center. So we have A, B, and C, and the center is kind of like in the middle of our angle, so to speak. Okay, so we use these 2 points to draw our intercepted angle. So let's say that we know that this is, what does that look like to you? Let's say 80 degrees. Okay, that's 80 degrees, that angle. What is this angle right here? 40 degrees. Oh, see, this is so easy you can even do it in your head. Right, so it's just half of whatever the inscribed angle is. And then there's another way that you could draw the inscribed angle. And that is, you have an angle that does not go through the center, and the center point is not in kind of the inside, if you will, of that angle. You still do the same thing. You take your point here and you take your point here, and you draw your angle. Let's say that this angle, this time, this big angle, is, I'll make this a little bit harder for you. I'll say that it's 88 degrees. So what is this one going to be? That's right, it's going to be 44 degrees. So that is how you measure inscribed angles. They are always half of the intercepted angle. And it doesn't matter if the inscribed angle goes through the center point, goes around the center point, or avoids the center point altogether. It does not matter. It always works out this way. Now, if you don't believe me, which would not surprise me, because this is kind of amazing that it always works out. If you do not believe me, tonight, while you're sitting down watching some mindless dribble on TV or the Cubs game, you can draw yourself some inscribed angles of various kinds, and you can take out your little protractor and you can measure what those angles are. So this one is about 28 degrees. Okay, this one is about 28 degrees. So what do we think our intercepted angle is going to be? Well, our intercepted angle should be twice that. So 28 times 2, what is that, 56? Let's see. Sorry, I put my pen in my mouth. I forgot I was recording this for all posterity. Okay, let's see. Yes, it is going to be about 56. Actually, it says 52 on my thing, but that is because I don't have a perfectly drawn circle here. Oh, and also I see that I can now change this. Okay, I could fiddle with this stuff all night long. I'm just going to prove it to you. Prove it to myself. Prove it because it's so cool. All right, so this is 25 degrees. 25. And so we would expect this one to be 50 degrees. And sure enough, if you line it up ish to account for my ish, I actually get that it is 49 degrees, which is close enough to 50 for a woman who did not even use a compass to draw that circle. All right, so I think this is super cool. You can totally impress your friends with something like this. I know, I suppose you have to have the right kind of friends, but they can be impressed. And now you know the inscribed angle theorem. Congratulations.